Hi, good morning, good afternoon, and good evening, everyone, and welcome to today's EAAFP webinar, Bringing Good Connections to Life, the EAAFP 2020 World Migratory Bird Day webinar. This is Vivian Fu, the Communication Officer of EAAFP Secretariat, and I am the moderator for today's webinar. I wish everyone is staying safe at home and staying safe from the COVID-19. I believe that we can still be connected socially, even though we have to be physically distance ourselves. Well, this situation requires us to be creative and adapt more to the technology. So here we are bringing to you the first webinar of EAAFP, the webinar series to celebrate this year's World Migratory Bird Day. The World Migratory Bird Day is an annual global awareness raising campaign led by the Convention on Migratory Species, CMS, the African Eurasian Waterbird Agreement, IWA, and Environment for the Americas. This event highlights the ecological importance of migratory birds. And this year, the theme of the World Migratory Bird Day is Birds Connect Our World. With this theme, today we are very honored to invite Professor Theunis Piersma, a well-known scientist of worldwide, for his work on migratory water birds and contribution to many conservation projects. Today, he will talk to us about how migratory water birds can bring the connection between birds and connection between people. Before we get started officially, I would like to go over a few items so that you all know how to participate in today's events. In your control panel on your computer screen, you will see a notepad icon. This is the handout section. You can find out handout notes from Professor Piersma, go to webinar attendee troubleshooting notes, and a fact sheet about EAAFP. You are listening using your computer speaker system by default. So, yeah, before we have Professor Piersma, I would like to introduce our Chief Executive, Mr. Doug Watkins, to mark the opening of this webinar section.
Welcome, I'm Doug Watkins, the Chief Executive of the Secretariat for the East Asian Australasian Flyway Partnership. The Flyway Partnership is a voluntary initiative involving 36 partners. 18 of these are national government partners, 6 are intergovernmental organisations, 11 are international non-government organisations, and there is one international corporate partner. The partnership is guided by a 10-year strategic plan adopted by all partners. The theme of this World Migratory Bird Day is Birds Connect the World. Developing a connected network of internationally important sites for migratory water birds across the Flyway is a core aim of the Flyway Partnership. The Flyway site network has now grown to 148 sites and spans from the Arctic nesting areas to the staging, and for some species, the non-breeding areas in the North and Southeast Asia, and on to the non-breeding areas in Australia and New Zealand. Please enjoy the webinar and do follow up with us if you would like to be more involved in this Flyway conservation effort. Thank you.
Thank you, Mr. Doug Watkins. Now let me introduce our honorable guest speaker today, Professor Theunis Piersma. Professor Piersma is the professor and the chair at Global Flyway Ecology of the Faculty of Science and Engineering, University of Groningen. Senior research scientist from the Department of Coastal System, NIOZ Royal Netherlands Institute for Sea Research, visiting scholar from the Center of East Asian Australasian Flyway Studies from Beijing Forestry University. He is also the founder of the Global Flyway Network. Also, Professor Piersma was awarded with the Spinoza Prize, which is also referred to the Dutch Nobel Prize in 2014, and as awardee of Top British Ornithology Award in 2017. Today, his presentation topic is bringing good connections to life. For those who have missed the early parts about the introduction, you can submit your text questions to Professor Piersma by typing your questions into the questions panel on your control panel. And we will collect all these questions and address them during the Q&A section at the end of today's presentation. Now, I would like to pass the screen to Professor Piersma, and please enjoy the presentation.
Good morning, everybody. I wish you peace and health in all 4 seasons. This is what this banner shows at the entrance of a restaurant that's no longer there. In northern Bohai Bay in China, about 12 years ago, when we were visiting there, with the band swallow as the good omen, the omen of connections, the omen of migration. And it's a fantastic opportunity to give this talk today to you, because normally I would have been in Bohai Bay with the Global Flyway Network team doing all field work on the annual birds coming through China on their way to the breeding grounds. And this is a picture of our normal morning in China. Now I can see my own screen, yes. Last year, we celebrated our 10th field season with our colleagues from the various universities, Fudan University, Beijing Normal University, and Beijing Forestry University. And it's too bad we can't be there, but with all this new technology, at least we can share thoughts and see each other in a more virtual way. So these were my introductory words. Not being in China, I miss it a lot, but still being able to talk shorebirds. And what I talk today about is bringing good connections to life. All kinds of different connections. So let me elaborate a little bit on what I regard as connections. Of course, there is our connections with the birds, whether we do this from a scientific point of view, or whether we do it to talk about these birds for public outreach because we like them, we find them important, and we want to tell about that. And all this comes together in the issue of the conservation of things that are rather threatened in a world that gets ever smaller, because there's ever more people wanting ever more things. So these are the connection with the birds. But in order to do this, of course, there is the connections between the people, like between you all over the world, especially in Asia, and with me here in the Netherlands and Friesland. And then there's the connection between the birds. Birds have to tell each other, they tell each other various things too. And perhaps most importantly, there's the connection between the birds and the environments. Those, the reasons that they travel the whole world in the first place. So these are the things I'm going to talk about. And I'm going to talk about especially satellite tagging. But before I get there, let me introduce our 2 main techniques to say more about the life of these small migrants. So these are 2 red knots, both marked with color rings and with satellite tags. Now these individual color marks, and you see the 4 rings on the leg and a flag, in this case birds in Mauritania, they are individually marked to do demographic bookkeeping. And the demographic bookkeeping consists of marking the birds and then going out as often as we can and look which birds we can see, which individuals we can see. And if we see an individual, we know it's alive. If we don't see an individual, we don't know very much actually. We know that it's possibly dead, or it's possible that we haven't seen it. And a lot of our effort of our group goes into the advanced statistical computations to separate not being seen from not being alive anymore, because not being alive anymore is of course a very important metric to study if we want to understand population changes. And of course, because these birds are recited in various places, we also say something about migration. Then if we go to the right birds, This is a bird being equipped with a solar-powered satellite tag. And these are fantastic tools for migration and habitat use, as I will explain later on. And actually, if the bird survives with the tag, and if the tag is fully operational, we can also look at the moment of death on the basis of these satellite tagged birds. I will not dwell a lot on that. So let me briefly go back to color ringing now, because that's really the start of the whole Global Flyway Network. And it started, and this consists of color ringing individuals, like this group of knots. There's 2 birds here with identifiable color marks. Actually, these are birds marked in Northwest Australia in Roebuck Bay and photographed here in Nanpu in China. So these 2 birds are alive and they make a connection. And the work started in my home turf in the Wadden Sea in the Netherlands with the marking of red knots of sanderling, bar-tailed godwits and black-tailed godwits. The last one is actually a breeding bird here. And these birds have a migration to the west of Africa, which is a place I've been coming for a long time. And in 2002, we started a project there marking red knot, sanderling and bar-tailed godwit. And these were all very successful programs. We thought we could say a lot about these birds. We could follow their populations, their life and death. And in 1996, we had a chance to also start this project with the help of BirdLife Netherlands in Northwest Australia, where Chris Hessel runs this project up to the day of today. So this is all well, this is all going on. And in the meantime, we have satellite projects in many parts of the world, but a concentrated effort is in these 3 sites, trying to understand survival of these birds in relation to environmental conditions. But when we catch the birds, we also like to know more about the individuals, which we only recite a couple of times. And this is when solar-powered satellite tags came into the use. Now I want to explain you a little bit more what a solar-powered tag is and how we use it. So actually, I hope you can see it. This is a model solar-powered tag. Actually, this is a 2.5 gram tag, one of the latest designs. It's very, very small, you can see it. And these tags are put on the back of, for example, a red knot, you can see here. And the whole attachment problem is a big one. We've studied that for years and years and years, but now we have the material and the design of the attachment that we think that these birds are not hurt at all. And given their performance, actually, I don't think they are much of a burden at all. And I hope you can see this here. Maybe you can't. It's put on the back, and what a bird does is it has to get used to it, and then it becomes part of the body. And most of the time, actually, these tags are preened under the back feathers. So there is a tag on the bird, and this particular tag sends a digital signal to the satellites. In this particular case, to the Argos satellite assembly, which is revolving around the world, and it's using the Doppler effect to calculate the position. Now on the left you see a very technical explanation of the Doppler effect. I don't expect you to understand it. The point is we have satellites that are connecting with the bleeps sent by the little tag. And here then is the whole process, which I'll take you through. This is already an old publication from Japan, which I'll explain in a minute. And from this, we go to MoveBank. So all the data are stored on MoveBank, which are then processed here in the Netherlands for you to access at the Global Flyway Network site. So let me explain a little bit more. So here's a crane in the middle picture. It has a tag which is sending its signals to a satellite in the Argosat. This is received by a ground station and is then processed by the Argos Global Positioning Center in Toulouse in France. This information is then being sent a couple of times a day to MoveBank. depository for animal tracking data. And what I hope you will do when you log into the global website and you go to one of the web facilities, every time you renew your data, actually, this website designed by Bastian Blau, he is working on this still as of today, www.globalflywaynetwork.org, will take the data from MoveBank and you get the very latest information that you can get. So all of you can play the role of researchers trying to find out what's going on. So maybe you will start a day like I do and end the day with looking up where the various birds are in the world. But this is getting more interesting when we go further to the talk. So this spawned this view now. This is a picture of yesterday, the various birds in various parts of the world that we follow as Global Flyway Network right now. From New Zealand, from Northwest Australia, from Oman, from Mauritania, and from Guinea-Bissau, birds flying north right now. Now, the fact that you can have such a fantastic small transmitter is due to the fact to a single person called Paul Howie, who runs his company Microwave Telemetry in the United States. And this is Paul Howie looking at his latest invention, the 2-grammer that we had. And Paul has a long history of designing these tags. He started off with tags that weighed 30 or 40 grams to put on very big birds, and they got smaller and smaller and smaller. Now, this was the phase about 14 years ago when we had tags which were about 20 gram. They didn't have a solar panel and they had to be implanted in birds. So this is a kind of it looks a bit like a root procedure. Here is the vet, Dan Mulcahy, working on a sleeping bar-tailed godwit in Northwest Australia. But actually, it was a fantastic procedure. This is still a sleepy bird measured by Bob Gill. And after half an hour of sleep, the birds would wake up, and only an hour after the operation, the birds would be released in the bay. And on this basis of these implanted satellite tags with a battery that would last for various amounts of time, we had our real first evidence of these incredible flights that these individual birds can make. Of course, a lot of you will now think about E7. And E7 was the bar-tailed godwit that was marked at Pukororo Miranda Shorebird Center in New Zealand in early March 2007, where it departed on the 17th of March, flew to the Yellow Sea to Yellowjang, crossed over to Alaska for a breeding season, and then came back to New Zealand in this fantastic long flight. Now, it was an incredible adventure to be part of that particular flight, I must say, especially the return flight. But before we go there, I'll take you into the life of the bar-tailed godwits, because of course they do all these migrations for a reason. They winter in places where there's food and safety, and they go to places where they can reproduce, i.e. the tundra of the northern parts of the world. And here is two male bar-tailed godwits having a fight about the territory. And here you may be able to detect it is a male on the nest, and the female is approaching the nest from the right, and it's time to take over incubation duty, which they share. And this is a few seconds later when the female has slightly prodded the male going off the nest and going to incubate the eggs herself. And this will take about 3.5 weeks, sitting on the eggs, sitting on the tundra, and then there's the freshly hatched young. These are probably 1 or 2 days old, and then they grow fast, fast, fast. In a couple of weeks, these very small little avian beings are turned into something that is fed and flighted. And in Alaska, they go to the coast where there is extensive mudflats, and this is the place where they fuel up for the long flights. And what is always interesting is to find out what they fuel on. So a couple of years ago, we had the opportunity to visit the Yukon-Kuskokwim Delta and sample all the intertidal flats where these birds were feeding from the boat, but also walking on the mud flats. And what we found is lots and lots of food, small bivalves, worms that these birds are feeding on to get very, very fat. And probably a lot of you can see that these birds are very fat. Normally, when a light wattled godwit stretches its wings, it will fly up immediately if there's a little bit of wind under its wings. These birds, they have to run for a long time before they are airborne because they consist for 50 or 60% of fat. And then at some late afternoons, they fly up with the Alaska Peninsula in the background and they take off to the south. And that's all we knew for a very, very long time. And because they were so fat, we thought that they might cross the Pacific. And actually, that is what E7 showed us, but only showed us in the last minute. So this is an implanted satellite tag with a battery. And in the course of that whole summer, of course, the battery was losing power. So as it was flying over the Pacific, a couple of months after its departure on the 17th of March, we got this picture from Lee Tibbetts, who was mission control and informed us of what was going on. And on the 2nd of September, she was there, E7. And this is the mail we got from Lee Tibbetts, this small privileged group that was part of this. And she says, Godwit update is going to be a nail biter. E7 is on her way back to her southern home. Well, why was it a nail biter? The nail biter was that we get information on the voltage of the transmitter. And you can see that the voltage in the transmitter was falling rapidly during the flight across the Pacific. So the question was, will we witness her arrival in New Zealand or won't we witness the arrival in New Zealand? Now here she was on the 6th of September, still giving signals, so that's very good. And eventually she arrived on the 7th of September, very close to the place she had been marked, in the Firth of Thames, close to Miranda. And these were the very last signals we got from her because then the battery was empty. Nevertheless, E7 was seen in the years following that, still carrying the transmitter. This then yielded this fantastic picture of a bird circumnavigating the biggest area of water in the world, half the world, so to speak. A real record breaker, and we all came to love this particular picture. Well, actually, this was big news in New Zealand, but it was also big news in the rest of the world. And this is 12th of September, only a couple of days later, when a Dutch daily newspaper, Algemeen Dagblad, publishes about this amazing flight, the circumnavigating of the Pacific. So Godwit breaks all the flight records and so on and so forth. This was world news. E7 became world famous. Bartel Godwits got the public attention I think that they deserve. Okay, solar-powered satellite tags is now the answer. Not an implanted transmitter, but a transmitter that can last for a lifetime because it recharges itself with the sun. A fantastic tool. I'll tell you more about it. Before we go there, I would like to ask you a question. What are the benefits of solar-powered satellite tags to study birds' migration? A rehearsal.
So our first polling question is, what are the benefits of solar-powered satellite tags to study birds' migration? So please select your answer and then click submit to us. We will close the poll in 1 minute's time. Yeah, you have 10 seconds to make your answer. Okay, so we have now closed the poll, and let me share the answer. That's what you have voted. So most of you have voted all of the above. So let me resume to Professor presentation. Yes, Professor, your screen is shared again. So Professor, your screen is your presentation can be go on. The polling is now finished.
Okay. Good. Well, I didn't see the results of that poll, but I hope it will get you thinking, because of course I'm now going to elaborate on these particular questions. So you had a little bit of time to think about it, and now we carry on. So what are the benefits of solar powered satellite tags or study bird migration? You've made it up in your mind, and I've made up something in my mind too. So let me go there. So this was a picture of Chris Hessel working from Broome for Global Flyway Network, and Jenny Chan, a PhD student, originally from Hong Kong, working in the Netherlands on the satellite tag birds. And Jenny has been working on great knots equipped with 5-gram solar satellite tags. And she has been working up the results for a long time. She published about it, and she very recently published a feature that is very, very useful for conservation. And her feature is called "Where Do Great Knots Stop During Migration?" A summary of her analysis. And actually it's a very nice interactive feature. Let me show it to you. So this is an individually marked great knot, colorings, satellite tags. And this is a picture of all the sites that we discovered through the use of these satellite tags that are being used by great knots. And that had a lot of discovery in it. So let me explain. So the dark blue sites and the size of the dots is the relative use of that site by great knots, were known sites for great knot. So these were sites that were in the literature as being used by great knot. And then there were sites used by the satellite tag great knots that were known sites for migratory shorebirds. So especially in southern China, you see sites that were known to hold migratory shorebirds, but not known to hold great knots. So we discovered, you can say, a lot of new sites. But the biggest surprise were all the sites that were completely unknown to science and conservation. All the sites, especially in Indonesia, in the Philippines, southern China, Vietnam, but also in Russia, that were not known to science and conservation at all, that we discovered through the use of satellite tags on only 20 or 25 great knots. Quite amazing. And in this interactive feature, you can actually click on all these different dots, find the name of the places, and learn about all the sites that they don't use, that they use but were not known. And in the formal paper published in the Journal of Applied Ecology that you see here, we actually make a summary of the unknown sites, which surprised us a lot. So in Russia, about 50% of the sites that great knots used were not known to science and conservation. And even in the now well-studied Yellow Sea, about 40% of the sites they used were not known. In southern China, almost 60% of the sites were not known. And in Southeast Asia, none of the sites that great knots used were known. And this then is the first incredible benefit of SAT tags. So SAT tags give spatially and temporally unbiased data on distribution and occurrence. These birds go wherever they want to go. We can watch behind our computer screen by that time where they are. We are not hindered by problems of COVID-19 viruses or public access or other political problems that we can't go to because the birds show us. So we get fantastic spatially and temporally unbiased data. Very, very important to describe the real situation. So after great knots, I will go back to Bartel Godwit, kind of the stars of this talk. And this particular Godwit comes from New Zealand and has been marked this winter. And it's called 4 blue, white, red, blue. So you can see in the left leg, you have to turn around. You can say blue over white ring. And then on the right leg, you can see a white flag over a red band over a blue ring. And that white flag is at position 4. Upper right, upper left is 1. Upper right is 2. Lower right is 3. Lower left is 4. So that's where the 4 comes from. Blue, white, red, blue. And this bird was photographed in South Korea by Andreas Kim. And perhaps you can see, or you did see, the satellite tag sticking out of the back, the little antenna that sends all this fantastic information. Now this bird had just flown all the way from Miranda in New Zealand to South Korea, to Andreas Kim's site, to Shinan County. And what you see here is the local movement of that particular bird in that area, yielding information on its site use. Andreas sent me some photos of his place, and this is Shinan Country, South Korea, an area with lots and lots of islands, with intertidal flats, and a lot of beauty, and about 1,000 islands and islands, in fact. And what the people there are trying to do is to make this into a protected area. Parts are protected already, and the region is listed for UNESCO World Heritage Site recognition. And now there's 4 blue, white, red, blue. And Mr. Kim immediately saw the use of this particular bird in the argumentation for the UNESCO World Heritage Site recognition and is going to use it. A fantastic result, of course, that a bird marked in New Zealand is put to good use, and Mr. Kim is developing this website on its local movements. It couldn't be better, and we hope the group is very successful. And this is not a first example. Another example is actually what happened over the last couple of years, again with Bartel Godwit, showing that an offshore fantastic intertidal area, the Dongsha shoals of Rudong in Jiangsu province in China, is actually being used by Bartel Godwit and by great knots. This is an area that's far offshore, very difficult to access, a little dangerous to access, and nobody really knew whether these offshore areas are actually used or not by Bartel Godwits and great knots and any other species, but these are the 2 species we have satellite tags on. And in analysis by Ginny Chen, we could show that indeed they can use these sites very, very well, and it was very gratifying that on the 217 Yantian meeting on the protection of intertidal flats, Professor Lei from Beijing Forestry University was presenting these very, very fresh results, indicating the importance of the Dongsha shoals. So these satellite tags inform and underpin the design of nature reserves, even leading, hopefully, to the recognition of World Heritage Site. The second benefit. So let me go back to the birds that were marked in New Zealand this winter. And this is Bartel Godwit 4 blue, blue, white, yellow. And this is a picture when the bird was still a bit stressed in winter plumage at Pukorokoro, Miranda in New Zealand. So this was 30th of October. And this bird made a flight to the Yellow Sea and meanwhile is on its way to Alaska. I will come back to this bird later. So 4 blue, blue, white, yellow. Now, if you look to this track, it's rather linear, you could say, a little shift in the Solomon Islands, but then something is really happening when it's approaching the Yellow Sea. So we'll magnify that part a little bit. So it's coming from the southeast, heading towards the Yellow Sea, and it's taking a turn to the right, and then a sharp turn south of Japan to the left. Now, very often this indicates something to do with winds, because you realize, of course, that birds are flying in the medium, the wind, the air, which has the same kind of speed relative to the Earth's surface as the birds themselves, or faster speeds very often. Now, there is a fantastic tool to look at this, and this is the earthnullschool.net, which is accessible for anybody. So if you do the reconstruction, this is what's happening. So this is the situation on the 30th of March. And what has happened is that when the birds, blue, blue, white, yellow, approached the yellow sea, it was all of a sudden fiercing, very, very strong northern winds coming out of the yellow sea. So it was pushed back, you could say, almost towards New Zealand. So it tried to skirt that problem, and then just south of Japan, it decided to give up. So hitting very unfavorable winds upon the approach of the Yellow Sea, and then deciding to take a shortcut to Shanghai. So that took a day, and after a very brief stop, the winds changed, and here you see the wind picture on the 16th of March, and then it carried on to Yaoyang with favorable winds. So this is very interesting. So these birds, and I just did this here sitting yesterday, looking at the wind maps. You can go back in time, you can go to, this is the surface level winds, but you can also look at higher winds, and you can reconstruct what's going on. And you can do this more formally, of course. So the set tags yield very precise information on how individual birds deal with winds, and of course, other geographic features. There is no better tool. And actually, I recommend sort of playing with the earthnullschool.net facility. It's very easy to handle, and actually this picture was taken 2 o'clock local time, your time in Asia, what the wind situation was right now across the Western Pacific. And actually, when you look at the site, it's all animated, so it's more beautiful than what I show here. So this leads me to the next thing. And this is this track. And this is old school. We don't have the modern website yet. Google Earth pictures of 2 tracks. White track and a pink track. And they both end up on the China coast. But look at the white track. What's happening here? All of a sudden, this bird, which is flying towards the Yellow Sea, towards Korea, is taking a turn and going back to the China coast. And this bird actually is not coming from New Zealand. This bird was coming from Northwest Australia. So it's taking a sharp turn. And when a bird takes a sharp turn, this usually means something is going on. So on her way from Northwest Australia, she really made a sharp turn and went to the China coast. So this is the turning point. And this is the 9th of April, just before it happened. And although I didn't put arrows in this, this means northerly flow. So she was in a wind flow that would bring her to the China coast very, very nicely. It would bring her to Jiangsu coast, in fact. But at the point of the turning, actually the wind had gone worse within a day. So very favorable winds had turned into opposing wind. And like 4 blue, blue, white, yellow that we saw a minute ago, it decided to take a shortcut. It was hitting unfavorable winds upon the approach of the Yellow Sea, all of a sudden, and decided to make a shortcut and went to Wenzhou Bay, where it arrived on the 11th of April. And actually, it arrived together with another bird that took a different route, and they both ended up in Wenzhou Bay. But immediately after arrival, these 2 godwits from Northwest Australia disappeared. They suddenly disappeared. We have never heard from them again. We haven't seen them again. And in all likelihood, they died. So, of course, we were very aware of that. And through Nicola Crockford, we approached the local people. And actually, our team, and this is Gubo Peng in Wenzhou, was also doing observations. And one of the striking things there is that a lot of the mudflats are covered with nets to protect the mudflats. But of course, this is a very, very dangerous thing for birds that get entangled in these nets. And actually, this is not a problem of Wenzhou only. It happens all over the place. And these are some very fresh pictures, very dramatic pictures from Yaoyang, where Xiaodong and the team from Fudan is working right now. And here's a bird that got entangled and didn't survive it. But on the right, you see a bird from New Zealand. You recognize a coloring combination that was rescued by the research team at Yellowjiang just a week ago. So that bird is happily flying again, but this is a real problem on many of the Asian sites. And what we have here is evidence that is happening. So the satellite tags provide a real-time warning system of new and unrecognized threats, sometimes unrecognized threats. For example, these nets on mudflats. Okay, so I go back to the previous one. So that's 4 benefits. Now I go to another one. And in order to develop that benefit, the 5th and last benefit, I have to go to my own country. And on the left here, you see the black-tailed godwit on a typical pole separating different kind of meadows. So the black-tailed godwit is a national bird of the Netherlands. 80% of the population breeds in our country, of this particular population of black-tailed godwit breeds in the Netherlands. And really it's an icon of our historic flower-rich meadows that have almost disappeared. Flower-rich meadows are a wonderful thing that yield beauty, nice smells, nice sounds, inspiration, and has been a driving force for a citizen science group called King of the Meadows. We pay respect to the black-tailed godwits and its habitats because we like the black-tailed godwits and we like the habitats which are endangered by the encroaching, still ever encroaching industrial agriculture. One of the stars of this whole public outreach enterprise is this particular godwit. And she is called Amalia. This is Amalia upon her release in southern Spain in the Extremadura, just freshly carrying her satellite tag. And Amalia has shown us a wonderful story. I don't have the time to elaborate on that. She has taken us to Africa 7 winters, back to the Netherlands, and 7 springs. And then last year, she lost her tag. So the tag didn't outlast Amalia because we know that she is still alive. We saw her in southern Spain this spring. But now that she doesn't carry a tag, she doesn't carry the story further. But we had 7 years of wonderful Amalia stories that we could share with everybody. And actually, this was the reason that Bastian Blau developed our first outreach site, the King of the Meadows transmitter site, which is still in the air. It's now being replaced by the Global Flyway Network site. And here is a picture of last spring with all these black-tailed godwits migrating from their wintering areas in West Africa to the Netherlands. Now, this particular effort has inspired lots and lots of people. Normal citizens that would only talk about it at birthday parties, but also lots of artists. So there have been public performances in the field. There have been concerts, Conference of the Birds, for example. There have been theater plays talking about the issues of our countryside, inspired by Amalia and the other tag birds. So, and then this also inspired the Global Flyway Network site that we have been working on. Remember that I told you how exciting it was to follow the fate of E7 when it was crossing the Pacific. And here it was this little privileged group that could see what was happening. And now everybody, all of you, all 300 something that are attending this webinar can actually go to the site and witness what is happening. For example, with these 2 birds. In the front was the Americas for blue, blue, white, yellow in the middle of the Pacific, suspended above Hawaii. What is it going to do over the next couple of days? You can now be part of it. The migrations to Alaska and Alaska, you can also be witness to the losses because that happens too. Life is rough and sometimes these birds die in the process. So the 5th benefit, SAT tags are an, I think, underused tool to engage the public with what it is to be a long-distance migratory bird. And here comes my second question then. Of course, satellite tags can't do everything. So probably you already are thinking about the things that solar-powered satellite tags cannot do. So I give over to Vivian Fu.
Yes. So now on your screen, you will see another questions, which is, can you tell which thing that solar-powered satellite tags cannot do? So you can select one answer and submit by clicking the button submit, and we will close the poll in 1 minute. So the options for you are provide demographic information of birds, provide information of birds migration, predict birds migration routes, give insights to habitats used by the tagged birds. Please be aware that this question is about what the satellite tags cannot do. You have 3 seconds left. Okay, so I will close the session. And now I would like to share the results to everyone. So the most people pick the option provide democratic information of birds, but there are second highest vote for the option predict birds migration routes. So back to you, Professor Piersma.
Okay, there we go. Well, you got a drill now. So of course I'm going to elaborate a bit on what satellite tags cannot do. So if you follow bird from your screen computer, which is very handy in these times at the moment, you're not in the field. So you don't actually see the birds, you don't experience what the bird experiences. So you can't do measurements of what it's like to be a bird in the field and what is important for this bird. So you always have to do this, because one of the big drivers of everything we see, of course, is food. There's also safety, a couple of other things, but food is a very important driver. And this is a particular important bivalve species called Potamocorbula that you find along the coast of China and around the coast of the Yellow Sea. This is a staple for many of these birds. So we have endeavored bringing together lots and lots of people to measure this food along the coast of China. It started a long time ago with Han Yongyan, Nikki, that started this kind of measurements in near Nampu in northern Bohai Bay. But now Gebo Peng, the guy, the third from the right, is leading teams along the China coast. And at the same time, the team from Fudan University is studying the bentos at Jialuiyang. So lots of things are going on and have been going on for the last couple of years, making incredible documentations of the food sources of these birds along the China coast. And obviously, that would be a whole talk in itself. So I'm not going to elaborate on that other than showing a picture from Gebo of the fieldwork of the last couple of days. I think this is Lanyungang, where the people are taking mud samples. They are looking at the birds, taking lots and lots of information at the same time on the crucial food conditions that are driving these migrations. And you can see they had some nice weather at times here, beautiful clean skies. And I'll show you one very important result, which is part of the thesis project of Gebo Peng. So sampling along the China coast, there is this incredible gradient from subtropical intertidal flats to really very boreal semi-Arctic mudflats in the north, which are ice covered for part of the year. And of course, you would expect along this coast to have an incredible gradient in the kind of fauna you would find in the mudflats that still exist. But actually, having studied the intertidal communities, and in this case from the point of view of the bivalves, we came to two conclusions. First is that in all the places along the China coast, the commercial species, the species that are sown and harvested commercially, they dominate. They can be very good food for birds though, but they are always linked to the human use. The other conclusion that we reach is that this expected latitudinal biodiversity gradient doesn't exist anymore. So more or less the community in the south is like the community in the north, because both are dominated by the commercial species, which are transported back and forth, and you'll find the same species all over the place. The non-commercial species, they still do show a latitudinal gradient. So it's fantastic that some intertidal flats still exist, but we have to be very aware that they are very, very dominated by what people do. And this is something that in the future managements of these intertidal areas, we have to give recognition. It's not necessarily a bad thing for the birds, but of course the fishermen will always feel the competition of the birds that are coming there time of the year and taking their shellfish stocks. So this then is what SATAGs definitely don't do. Even if we put these tags on, and perhaps it's even an encouragement, we still require tough on and in the mud research on crucial, what I call here, boundary conditions. And food is an incredibly important boundary condition. So, bringing good connections to life. I'm coming to the end of my talk. So we talked about connections between people. We talked about connections with birds. And briefly, in the end, we talked about connection between birds and environment. And earlier, we talked with connection between birds and the wind environment. What I didn't talk about at all is the connection between the birds, how individuals use this other information, perhaps use these other flights, use whatever to do whatever they do. This is because I don't have a lot of things to say about it, and maybe this photo taken by Jesse Conklin this particular spring in New Zealand says it all. A flock of battle godwits, a beautiful picture. The leader in the front, is that the leader calling out, followed by a group. Connections between the birds. So at this point, I would like to close, but not before giving you the latest news that I just got from Phil Badley in New Zealand on our heroes for blue, white, yellow, and YCA. So where are they right now? Well, this is where they seem to be. So the lower track is forward blue, white, yellow, going straight east across the Pacific and having already flown 8,500 kilometers and still a couple of thousand kilometers away from Alaska. And then there's YCA, having flown about 7,000 kilometers and taking an early shift of direction towards the north right now. They are there in the middle of this immense Pacific. We don't know how they navigate, but obviously they seem to know what they are doing. And actually, they may be riding the fantastic winds that you find at high altitudes, because this is a picture of about 5 kilometer height of strong easterly winds that could carry them if these birds make good use of them. So I'll go back to this picture. Let's see what happens over the next couple of days. And with this, I'd like to close. I thank you very much. People in various parts of the world, it's very exciting to do this. Of course, I lack the direct communication. I think you could see me, I couldn't see you, but thanks for attending. And the floor is open to questions. I'll give the floor back to Vivian. Thank you very much.
Right. Okay. First of all, thank you, Professor Piersma, for linking us to migratory water birds and telling us how the birds, with the use of tracking devices and how it links to different people within and outside the East Asian Australasian flyway, and even linking to the livelihood of people. So now we are going to begin the answer the questions submitted during today's presentation. So first of all, dear attendees, as we have over 300 attendees from all over the world today, Yeah, we are only collecting text questions to Professor Piersma only, and you can still submit your questions, but we don't have a lot of time left for this session. So let me bring you the first questions to Professor Piersma. This question is from Boxing Tang. Thank you, Professor Piersma, for the presentation. Can I just ask if there are any studies done to look at how has the colored text or satellite text affect the bird's mating behaviors? Yes.
Yes, it is a very good question. Actually, most questions are very good. Indeed, of course, when you attach something to a streamlined bird, you would expect some effects. So we see that they take a day to adjust to putting a tag on. And then they do the things. And we have just seen that blue, white, yellow is already flying 8,500 kilometers after having done another 9,000 to get to the Yellow Sea. So they don't seem to be hindered. But we have done an experiment historically with Bartel godwits, which is being analyzed at the moment by Ginny Chan. Now we use 5-gram transmitters. Previously, we used 10-gram transmitters. And indeed, we see that the birds with 10-gram transmitters do something slightly different. So what is slightly different? They have a bigger likelihood of not making the final flight to the breeding grounds. That's one difference. So they either go or not go. The 5-gram tag birds, they all go. Some of the 10-gram tag birds, they don't go at all. They don't have a difference in survival, probably because the 10-gram birds, they realize they have a slight handicap and they do things differently. So that's why the miniaturization and the improvement of the technique of attachment is incredibly important. So we don't take this lightly at all. We are interested in what birds, real birds, are doing, and we spend years and years to optimize that. But yes, of course, catching them, putting a tag on is a little problem for them, but we think that with these small tags, we don't see any effects, if any at all. That's my answer.
Okay, so another questions from the audience. This is a question from Andrew McCafferty. The question is, the godwits who died on the Chinese coast, do the texts stop transmitting when the birds die? Or do you just see a series of data points that are clearly not moving? Or do you also get heart rate data or body temperature readings that tell you when the bird is alive? So this is the questions.
Yeah, that's a very nice question again. No, right now, these satellite tags, and there's a very small one here. You probably can't even see it. Here it is. So they are just attached on the skin. So we don't have any other data other than that the 5-grammers have the temperature. They have temperature information, and we always log the voltage, so how much they are charged. Now the combination of temperature changes and voltage changes, we can distinguish between the death of the tag or the death of the bird, to some extent at least. And further on, we can sometimes see that birds are getting into problems. They start to make funny movements. And we just had an example of a Bartel godwit across the Gulf of Biscay between France and Spain, where a bird stopped making circular movements, and now it's off the radar. We have no idea what happened, but in all likelihood, it died in transit. So temperature is information, disappearance of the signal is information, but also the behavior before the loss is also information. So it's still an inference. We don't have direct data on the situation on the birds. Maybe that comes in the future, but it's still a bit indirect, but very often we can pinpoint death. That's my answer.
Okay, great. Because we have very limited time left, I can combine 2 questions about the satellite tags. So these are combined questions from Isabel Tang and Freddie Kerna. They ask about how long does the satellite test last, like the lifespan of the satellite tags, and also how exactly is the tag is attached on the birds.
So this is how, if I understand, this is the question about how long they last, the satellite tags.
Yes, the lifespan of the satellite tags, and also how the tags are attached on the birds.
So let me start with the last question. So I'll show it to you. I hope you can see it. So here's this is the solar panel, this is actually a dummy, because the satellite tags are too expensive to have them freely available. You see a couple of attachments. So we have special thin soft threads with which we put them, in this case on the red knots, with a backpack. The Battle Godwits have very long legs, so then you have another type of backpack around the leg. So that's all technical. It's like a little trouser that you put on, so to speak, very tiny little trouser. Now to the lifetime. So actually, we are still finding out, because these products, they are so new that we don't know. So far, I think the longest living microwave telemetry tag on a shorebird was 9 years, and on curlews in the United States. And in that case, I think the curlew died. Our longest so far was Amalia, and that was 8 years in operation. And then the tag still operated, but was lost because the attachment broke. We could see that. It was flipped to the side, and then it happened. So the plan is actually that these tags will last even longer, that they will outlive the birds. But we can only find out by doing it, because this is very young. Our demography work has been going on for 14 years now. Our tagging work has been going on for 7 or 8 years with the solar power tags. So we're in the process of finding out. But the idea is that they will last a lifetime. And of course, most of these shorebirds will have an average lifespan of between 7 and 8 years anyway. So this is totally achievable. So that was my answer.
Okay, great. So we suddenly have a flooding of questions, of more than 30 questions, which we cannot answer all of these. So we are going to collect all these questions, and then we try to answer them, and then send back to you all with the answer from Professor Piersma of the EAAFP Secretariat.
Yeah.
So
thank you. Questions.
Right. Okay, so thank you again to Professor Piersma for bringing us this very inspiring webinar. And also thank you everyone for attending our first webinar. I'm so pleased that we have over 300 attendees of this section. So yeah, thank you very much. And we are going to have the next webinar, which is now scheduled on the 9th of May. 2020 with the for the World Migratory Bird Day. That is the EAAFP Virtual Fun Day to celebrate the World Migratory Bird Day. We will have 4 artists to tell stories, sharing flyway adventure with migratory water birds, a mini concert, and a virtual art gallery tour. So yeah, it's for fun, for family, for kids. So you can find the registration link in the chat box here in this control panel, and also in our follow-up email. You can also follow more of EAAFP activities on our website and social media channels. So here shows the screen to you. And once you leave today's webinar, you will receive a follow-up email with a survey on the presentation. And we will appreciate if you could complete that and provide your feedback. And this email will also include a link so that you can watch this recorded webinar today. And we will also share the recording of the webinar to our YouTube channel afterwards. On behalf of the EAAFP Secretariat and our presenters, thank you very much for joining us today. Your continuous support and interest is truly encouraging us for all the conservation work on migratory water birds and